Hello, and welcome to Introduction to Normalization. This is Bob Niels. Now that we have done a pretty good job of designing our databases and putting them physically into SQL Server, and also getting to the point of joining them all together in regards to developing relationships between our tables, and also developing joins that kind of brought the information out, we need to talk about one last topic that will kind of complete everything that we've been doing, and that is normalization. You probably have heard that term already. It's kind of hard to avoid when you're talking about databases. And it's a term that really kind of provides the means to ensure that our database is at its peak efficiency in regards to how we develop it and how we store this data. So, what we kind of want to do now is kind of back up a little bit and make sure you understand this concept, and then also make sure you understand how to apply it based upon where we are right now. I hope that makes sense. I think it will. With that said, what this video is going to talk about is number one, we don't want to confuse you on this. We want to make sure you understand what it is we're doing. And we're taking a very cautious step by step approach on this topic. It's not hard, yet it's, as a matter of fact, in a lot of cases, you've been doing it already. But what we want to do is make sure you do understand where we are, what we're doing, and how we're going to apply it. We'll dive into what normalization is, and then the reasons for normalization, and then finally, we'll talk about the normal forms. Okay? In subsequent videos, we'll take these normal forms and we'll start applying them rule by rule, and you'll understand that when we get to there. Okay? Anyway, let's get started. So right off the bat, I don't want to confuse you, and this is what we're doing right now is not meant to confuse you. Uh, Basically what we have completed so far is I don't want to say another way, that's pretty much what I say there, but it is another way of creating a normalized database. We've attacked this from a design perspective. Okay. For the most part, with creating a database based on our understanding requirements, entities, and relationships, we are well on our way to a normalized database. We have, just by the fact of our design, uh, adhered to the rules, or I said the forms, I should say, the normal forms of normalization. Um, have we adhered to all of them? No, we have not. That's where we want to come back and make sure you understand what normalization is. Thus, you can make sure that we did adhere to all of them. Okay, so I hope that makes sense a little bit. So we're just trying to tighten a few things up. And once you understand normalization, I think you want to also understand design a little bit more and what we've kind of been doing all along. All right. So um, even with all this great design that we did, there is still room for our databases for databases that much better by continuing to analyze our tables. I'm sorry. There is still room to make our databases that much better by continuing to analyze our tables. Okay, meaning we can get into it and make sure that we are storing our data at peak efficiencies. Some of you may have already recognized that you've seen redundant data in your tables. You've seen opportunities where things could be broken out even more, probably than what you have done so far with our design. If you have, you're seeing what normalization is all about. Okay? But anyway, for us to really try to understand normalization, I got to go back to almost the beginning and kind of break down what normalization is. We almost need to go back to step one in a way. So what we're going to do this week is we're not going to build upon what we've done so far. So up to this point, we've designed everything, built our physical databases, blah, blah, blah. What we're going to do is kind of go back to and talk about normalization as if we have not done anything at this point in time. We're going to look at data and break it down. So if you could, I want to make sure that you approach this as a way of saying, okay, kind of forget about what we've done so far and just look at normalization for what it is. I hope that makes sense. Then what we're going to do is once you understand the three normal forms, we will go back next week and look at how to apply normalization with our database designs and sort of kind of put it all together. All right? So bear with me on this. All right. and kind of go with it a little bit, try to forget a little bit about what we talked about thus far. I don't want to say forget about all of it because I think it's going to help you understand this concept. But just kind of learn what normalization is, how to apply, and be patient until we put it all together in the end. All right? All right, let's get started. So with that, what is normalization? Well, the database normalization is a process used to organize a database into tables and columns. The idea is that a table should be within a specific topic and that only those columns which support that topic are included. Like I said, in a lot of ways, we've been doing that already, okay? However, if you break that sentence down a little bit more, the idea is that a table should be about a specific topic and that only those columns which support that topic are included. That might give us opportunity a little bit more to dive in and do a little bit more with our database, even what we have done thus far, okay? So our goal now is to make sure it is complete, where our approach may have left some opportunities for improvement of our database. Okay, so what we've done thus far is great. Kind of got us pretty far into the process, but there is some things we can still look at. But to be able to understand those things to look at, we need to go back to the very beginning in regards to what this thing's all about. Okay? We've always stated we wanted a database that is scalable, accurate, and efficient. In a sense, that is what the database, we wanted a database to maximize space. That's what I mean by efficient. Normalization, the rules of normalization ensures this. Okay? So, in the end, once again, if we do what we've been doing before in regards to the development and design of a database, and then apply the rules of normalization, or at least look at every table we have developed and with the eyes of normalization and making sure we're adhering to each of the normal forms, then we know we are complete. That's how it all works. All right. So what's the reasons for normalization? With that, there are four main reasons to normalize a database. All right. Ensure the database is scalable, meaning the database can grow without intervention. Minimize duplicate data, minimize and avoid data modification issues, and to simplify queries. Makes sense, right? So you've played with queries thus far. You've seen how those work. So they shouldn't be foreign to you at this point in time. The big key is scalability and minimizing duplicate data. Okay, by doing those, we're going to minimize and avoid data modification issues and other issues and accuracy, and also the ability to make sure we can search correctly. Hopefully, we can explain all this to you in grave detail as we keep moving forward. So let's consider this following table. All right, this is a very simple little table here. You can kind of look at it. We have a sales staff here. We have an employee ID, which would be our primary key. All right, a salesperson, a sales office, an office number, a customer one, customer two, and customer three. Probably something similar that we talked about earlier on in this course. The first thing you notice in this table, it serves many purposes, including identifying the organization's salesperson, listing the sales offices and phone numbers, associating a salesperson with the sales office, and showing each salesperson's customers. Again, we're going back to the beginning here. We're not building on what we've done before. So just look at this for what it's worth. This is not what we have done. I agree, we would never have developed a table like this. But to understand normalization, we have to go back to something like this right now. So let's kind of pretend that there was a table given to us, maybe by your customer or your client, and it looked like this, and they're asking you to normalize it. So when you look at this, the first things you should notice is this table does a lot. And what our goal is here is to have, when we have a table like this, the table should only have one purpose. Having a table serve many purposes introduces many challenges like data duplication. You can see that the sales office has Chicago twice. Data update issues. What happens if all of a sudden the sales office in Chicago changes its phone number? We have to now modify that in every record that has Chicago on it. That might not be a big deal when we only have 3 rows here, but if we have 1,000,000 rows, it could be an issue. Limitation on growth. What happens when Mary gets a fourth customer? Where does that go? we'll have to go in and intervene and to add that a column for the fourth customer, fifth customer, sixth, 10th, 100th, and so on. That's not scalable, correct? And then increased effort to query, so limitation on growth in that case, and then increased effort to query data. Uh, I'll show you that here in a second. What do we mean by that? It's pretty hard to query data in a table like this. All right. If I want to know, I'll show you here in 1 minute. Also consider if we move the Chicago office to Evanston, Illinois, to properly reflect this in our table, we need to update the entries in all the salespersons currently in Chicago. Our table is small enough, but once again, if it got larger, that could involve hundreds of updates. So these are modification issues. Also consider what would happen if John Hunt quit. If we remove his entry, John Hunt, we'll lose all the information about New York. That wouldn't be good. New York would not be happy about that. So with that said, you can see that an unnormalized table such as this causes a lot of issues. There are called modification anomalies. These are called modification anomalies, the things I just kind of talked about. But let's take a closer look at these one more time. The first one's an insert anomaly. There are facts we cannot record until we know information for the entire row. In our example, we cannot record a new sales office until we also know the salesperson. So if we wanted to insert a record here, let's just say Atlanta opened up and we wanted to add that office. Well, we can't add that office until we know the salesperson that's going to be in that office. That could cause issues. And once again, an anomaly in regards to an insert. Update anomaly. The same information is recorded in multiple rows. For instance, if the office number changes, we've already kind of talked about this, there are multiple updates that need to be made. Okay? A delete anomaly. We just kind of mentioned that. If John Hunt went away, then deleting that row can cause information losing New York office. That is called a delete anomaly. And finally, search and sort issues. The last reason we'll consider is making it easier to search and sort the data. If in our sales staff table, if you want to search for a specific customer such as Ford, we're going to have to write the query like this. Select sales office from sales staff where customer 1 equals Ford, or customer 2 equals Ford, or customer 3 equals Ford. Well, let's go back to what I just said. Wonder if we start adding additional columns in regards to customer 4, 5, 6, 10, 100, and so on. This query becomes unmanageable. We would have to have that OR statement for every possible column of customers if we continue to add. And I hope that you see with that right there, there's a lot of inefficiencies with our searching and our querying. Therefore, we need to dive into normalization. Now, as I said and repeated many times so far in this video, in a way we've been doing this, and hopefully you're sitting there already telling yourself, well, we have taken care of that. Great. Let's go back and kind of readdress, and we'll see what you've done so far in regards to these normalized forms and what we still have to work on in regards to our design thus far. The normal forms. I tell you, what's really interesting is, and especially in IT, you guys are all going to recognize this as you keep moving forward in your curriculum, that there's so many different interpretations and what do I want to say, interpretations, opinions, and definitions in regards to rules of normalization, and really a lot of things in regards to IT. There is no one right way, but in the end, hopefully we get to the one way that literally works. And so some of the resources that are provided with this video that you can go read, you're going to read different definitions when it comes to normalization. Some are pretty difficult to really understand what they're saying. Our goal is to keep it as easy as we possibly can. Okay, and so we're going to not really come up with our own definition, but we're going to come up with the definitions that we have found to be easier to understand, but in the end, get you to the exact same place as everybody else's definition gets to. I hope that makes sense. All right. Anyway, let's kind of dive into this. officially there are 5 rules of normalization, and there's other rules like this one called B, C, and F. I think there's even another one on top of that. So there's like 7 different rules of normalization that's out there. Rule 4 and 5 and those others are simply just they're advanced. I've never used them in my career. Uh, basically, the rules that you normally adhere to are the first, second, and third normal form, where the majority of your changes really comes into the first and the second. Okay? And so, but we're going to focus on the first, second, and third for this class. The other ones you can look at. They're out there. Go Google them. All you got to do is bring up normalization, and they'll show you every normal form and every rule that's there. But you'll recognize, and you'll also will read that the first, second, and third are used probably 99.9% of the time. The other ones are for those very unique instances. And again, I have never used them. What are they? Well, the first normal form for any table eliminate repeating groups of data. Remember that whole customer 1, customer 2, customer 3? That is a repeating group of data. That is a repeating column, okay? So repeating groups of data, or in a lot of cases, repeating columns is what we're looking at here. We want to eliminate that and put that into our own table. That is first normal form. Second normal form, ensure a table is in first normal form. You got to do these in order, okay? So second normal form says ensure a table is in first normal form and eliminate redundant data. Again, there's many versions of this rule, and you'll kind of read it a lot differently. But what it comes down to it is we're eliminating redundant data. We don't want data out there that we can't. We want to modify one thing that takes the place, and then that takes the place of. Let me say it again. We want to make sure we can modify one thing, and that's all we need to modify to reflect that change all the way through our database. Okay? So with that, we want to eliminate redundant data. The third normal form, ensure tables in second normal form, and ensure all attributes are dependent on primary key. What does that mean? So once again, different versions, no big deal. But for the most part, what we're saying here is we want to analyze every table and ensure that it's actually dealing with one purpose. Okay, kind of going back to how our example in this video talked about. It has one purpose, and with that, we want to make sure that all attributes is functionally dependent upon the primary key. What does that mean? It means this is that if it's not really attached to that primary key, if it's not really associated with that primary key, if it has nothing to do with the primary key, it's an attribute, yet it could be an attribute for other types of things also, not just the key. If it's not unique to the key, it's maybe a better answer here. Okay, then it needs to come out into its own table. That's what third normal form states. All right, makes sense? Zip code could be a great example for this. Okay, so if we have an address in there with a zip code is not functionally dependent upon a student's primary key, meaning there's a lot of students who share the same zip code. That's what that's saying. All right, we're going to go into more in detail on all of these. We'll talk about these in individual videos, and then we'll go ahead and apply them. And again, then you'll go ahead and practice. But anyway, this is the first video on normalization. I hope I made sense. I hope I warned you enough to not make this hard and not to get too confused based upon what we have done so far. So kind of clear your mind, relax a little bit, and kind of just understand these rules as it applies to our little examples. And I think in the end, you'll understand it completely. And in the end, you'll have a very good database and a very complete database.